In this video, we are going to be learning how the tilt of the Earth on its axis and its path around the sun causes direct and indirect sunlight to hit us differently, causing our seasons. Here in this demonstration, we're going to be using a wall and a flashlight to represent how the tilt of the Earth's axis affects our seasons. So I've placed a little mark on the wall here. It says you are here, so this is you. You're going to be on Earth, just looking up at the sun. And we're also going to be using a flashlight to represent the sun. As you can see, this is just a regular old flashlight, and I'm going to aim it directly at you where you are on the Earth. So imagine here you are looking up at the sun, and in this demonstration you can see that it is very bright. It is blinding. So blinding that we can't even read the words anymore. And there is very little angle here. The sun is pointing directly at you. We've all felt that way when it's a hot sunny day at the beach and you can just feel the sun beating down on you. Now, if I back away, you can also see that in this demonstration, the sun's rays are very focused. They're focused in one small area. And in fact, if I move away and try to show you how much light is spread to the rest of the wall, you can't see the rest of the wall because all of the sun's rays are focused in this one small area because the angle is a direct angle. It's pointing directly at where you are on the beach. The rest of this wall is completely dark. Now, all I'm going to do to change this is move the flashlight to the right so that I'm creating more of an angle. I'm not moving it further away from the sticker, the "You Are Here" sticker. I'm just changing the angle. So watch what happens. Watch what happens to that focused light. So instead of covering one small area, that light is now spread out over a much greater area. And in fact, you are able to see the entire wall. So it's still giving off the same amount of light, but it's not focused in one small area. It's spread out. So we're sharing that light, we're sharing that heat with the rest of the wall around us. And the only thing that changed was the angle. It's now indirect light instead of direct light. Now we're going to show what that looks like with our rotating Earth. So as we said, the Earth rotates on its axis, and it is tilted 23.5 degrees or 23 5/10 degrees. So I'm going to set up a demonstration. And in this demonstration, the flashlight is going to continue to be the sun, and the Earth is going to be over here. You can see I still left the "You Are Here" sticker at the top. You can see the "You Are Here" sticker. It's bright enough for you to see it. That means it's daytime, but it's not so blinding that you can't read it. And if you look at the way that we are tilted in this model, you can see that the northern hemisphere is tilted away from the sun, and the southern hemisphere is tilted towards the sun, so that it is receiving the direct rays of the sun. So therefore, it would be summer in the southern hemisphere. However, we are about as far away from that direct sunlight as we will get. Now we're going to move to the next part of our orbit. And in this part, the tilt has us not facing directly towards the sun or not facing directly away from the sun, but facing off to the side. So this direct sunlight is a little bit closer to us, but it's not right on us. Now let's move to the next part of our orbit. As we continue to make our way around the sun, at this point, the tilt of our Earth has us in the northern hemisphere facing directly towards the sun. Because we are receiving direct rays from the sun without much of an angle, you can see it is so bright, those rays are so focused on us that you can't even read the words on the "You Are Here" symbol. So you have to imagine that this is the hottest day in the middle of summer. And now we're going to make our way over to the last part of our orbit. where we once again are not going to be tilted directly at the sun or directly away from the sun. So you can see again, you can read the "you are here" sign at the top. We are receiving more of the rays of the sun than we were in winter, but not as much as summer because the angle of the sun is greater. So we are receiving indirect sunlight, not direct sunlight. Hopefully this video helped demonstrate why receiving direct sunlight at less of an angle gives us summer, and receiving indirect sunlight at a greater angle gives us winter. Also, it should model that when the northern hemisphere has summer, the southern hemisphere has winter, and vice versa.